The following is a continuation of Chapter 3, Automotive Tools and Equipment. The material comes primarily from the shop manual. These are some key things that I think need to be emphasized for your understanding and benefit. Chapter 3, Shop Manual. One of the things is when we use power tools, either air or electric in the shop, you always need to make sure that the electrical cord is not cut or frayed or showing any bare wires. By the same token, when you use an air line for a pneumatic power tool, always want to check and make sure that there's no cuts or bubbles in the line or blisters. A broken air hose can whip around the shop and cause significant damage to vehicles or personnel. So always check, make sure that your electric cords or air hoses are in good condition. If they're not, notify the instructor or the shop tech. When lifting a vehicle on a contact lift, always confirm the locations of the contact points. The picture on the right is an example of what you can find on Pro Demand in the computers in the lab. You can go to a specific make, model, and year, find out the exact locations for the contact points on it, and always lift your vehicle according to that. As you progress through the program and get into the in-person classes, additional specific lift training will be done during the in-person classes. Take care to always follow procedure and locate the lifts and the contact points as they're supposed to be. Failure to do so can cause significant damage to a vehicle or create a dangerous situation to personnel. Common mistake many new students make is to put lug nuts on wrong. One of the things you need to do is always check for a taper. The taper always goes to the wheel. Wheels that have tapered lug nuts like this use that taper in the wheel to center the wheels on the studs. So in other words, if we fail to put the taper to the wheel, that wheel can be mounted out of position. So this type of wheel, this type of stud, is what we call stud-centric wheel mounting. The wheels are mounted off the studs and the taper on the nuts. There is another option for wheel mounting, which is called hub-centric. This is where the center of the wheel actually mounts on the center of the hub. Those lug nuts are flat. There is no taper on that type of lug nut. So you may see lug nuts that do not have a taper, which is perfectly acceptable because that will be a hub-centric mounted wheel. But if you have a tapered lug nut, either open end or covered, always make sure that the tapered end goes toward the wheel because that is what will center the wheel on that hub or axle. Many automotive applications use interference or press fit when they're assembling parts. Bearings, hubs, shafts can all be interference or press fit. As a result, there are many specialty pullers and extractors used to remove or disassemble these components. A couple examples are shown here. Upper right would be a large hub puller, front-wheel drive vehicles, possibly rear-wheel drive. Lower left is an example of a puller that we can use for things like steering wheels or hubs on a vehicle, front-wheel drive, possibly a bearing puller. The lower right is another example of a puller that's used to pull a wheel hub off a front-wheel drive vehicle or possibly a bearing out of a front hub. These are just a few examples. There are many more types of pullers that can be used. So keep in mind, many parts are interference and press fit, so you may need these specialty tools in order to be able to disassemble them. There are several specialty tools for removing broken bolts, studs, or taking nuts from studs, or getting a broken bolt out of an engine block or cylinder head. The lower left shows an example of sockets that are specially designed to be hammered on to a rounded nut or bolt. They can then take that rounded nut or bolt and loosen it. On the right, we see a stud bolt extractor, sometimes referred to as an easy out. This is when a stud or a bolt is broken off inside a hole, like in an engine block, cylinder head, or chassis component. These types of parts can actually remove a broken stud or bolt from the vehicle, so it saves expensive repairs, but this is an option. As you progress your automotive career, you're going to find out that dissimilar metals can actually chemically react. So something like a steel bolt and an aluminum head can actually, over time, chemically interact and actually fuse themselves together. So dissimilar metals like steel and aluminum can actually create a chemical interaction between the two metals. What's required is anti-seize lubricant to coat the one before we put the assembly together. It only takes a minute amount of anti-seize to stop the chemical reaction, so be careful when using it. Don't put too much on. It takes a very, very, very small amount to be effective. Too much can damage components like brake pads, can damage components like electrical wires because it is conductive. So be very careful when using it and use a very, very small amount if necessary. One of the things I want to comment in this chapter on is the fact that when we talk about a car battery, there's two numbers that need to be committed to memory for the rest of your career. The first one is that a fully charged battery should have an open voltage of 12.6 volts. If any battery is tested at 12.6 volts, it's typically considered to be fully charged. So that's a vital number for you to keep in mind and remember. There's a second number, and this one relates to the battery's specific gravity. This is another test that we can do to the fluid inside the battery and tell exactly what its state of charge is. A fully charged battery should have a specific gravity of 1.265. So, again, those two numbers, open voltage of 112.6 and a specific gravity of 1.265, are both indicators that a battery is fully charged, and would be to your benefit to remember those numbers because you will see them countless times over your automotive career. That concludes Chapter 3. Shop Manual has got much more information in it, but many of those topics will be covered in the in-person classes in each specific class. For now, for the online class and this survey course that we're doing, I'm going to conclude Chapter 3. If you want to find out any more of the detailed information, you can always go into your account on Cengage. You have the access to the full book, shop manual and classroom manuals, and go in and see additional information. But that's about all we're going to cover for this week in Chapter 3, Tools and Equipment.